This is the mini lesson for multi-step inequalities. At this point, you've kind of solved all of these in the equation form. We're going to practice, having these more complicated algebraic steps involved within our solving process, but inequalities now instead of equations. Just some reminders at the top here. Remember, if it's possible, try to simplify each side first in the equation. If you need to distribute or combine like terms, it's always good to start with that. And then it's helpful to move all your terms with the variables to one side of the equation and all your terms without variables to the other side. And then combine like terms again if needed at this point, and then you know how to solve, and you'll solve using inverse operations to isolate the variable in graph. If you remember, when solving inequalities, there is one special step, one difference really, that you have to remember, and we'll get into it in this video, mini lesson video here, when you're solving an equation. It deals with negatives and a certain operation. Let's do a couple examples here. Example 1, Bryce has $350 for his birthday party and he wants to buy a Nintendo Switch. The Switch costs $213 and the games cost $65. And these are already including tax. How many games can Bryce afford with the Switch using only this birthday money? Write and solve an inequality. Okay, so it's helpful to identify your variable. What are we solving for here? We want to know how many games Bryce can afford. So G is going to be my variable. G can stand for the number of games. Okay, so he has a total of $350. That's how much money he's able to spend. I'm going to put that over here on the right. Often we put our total over there. What is he purchasing? He's purchasing the Switch, which was $213, and he wants to buy games. Each game costs $65. Figure out the inequality symbol here. Can he spend all of his birthday money? Yeah, so this can be equal. Can he spend more or less than the birthday money that he has? Well, if this is how much money he has, what he spends has to be less than or equal to it. He can't go over the money that he has. Awesome, let's solve. We're going to subtract 213 from both sides. There's nothing to simplify on each side first. $65G is less than or equal to, let's see, 350 minus 213. I can do that in my head here. Or really on paper, but without a calculator. Try to do as much of it as you can without a calculator, guys. Use that brain. Okay, then we'll get G by itself by dividing by 65. Now I can tell here this is not going to come out to be a whole number, and that's okay. So when I divide by 65, I get, I'm going to just pull my work up here. G is less than or equal to, and it's a decimal. Use your calculator for this one if you need, or I can tell it's going to fit in 2 whole times, and there's going to be a little bit more. When you use your calculator, it's 2.1. Now that answer doesn't really make sense for the situation. Since it's a real world situation, can Bryce buy part of a game? No. So when we're doing word problem inequalities, I think it's helpful to write a sentence for your answer. I like that. That's what I want to see from you. And also sometimes you have to make your answer better for the situation. So yes, G is less than or equal to 2.1, but now really what does that mean in terms of G standing for the number of games? It means Bryce can afford up to 2 games with his Switch and the birthday money. But that's really the main part here. Bryce can afford up to 2 games. He can buy 0 games, 1 games, or 2 games. He really can't buy part of a game, so those are all the answers. All right, good. Let's try another one. Here we have an inequality. It says solve and graph. Notice there are variables on both sides. I look at each side first. Is there anything I can simplify on each side? No. Then you're on step number 2. You're going to move all the terms of the variables to one side and move all the constants, the numbers that stand alone, to the other side. I do generally like to take the variables to the side where there are more. So I'm going to subtract 8y so that these cancel, and that will get my y's together on the right side here. This is a little tricky. A lot of times students mess up this minus 8y. Remember, you're always looking in front to figure out what sign it is. If I need to move this entire term over, this is a positive. That negative sign that comes after it is belonging to the 18. Okay, so we subtract 8y from both sides. These cancel. You're left with a minus 18, or a negative 18 now, is less than 6y. What do you do next to solve for y? Divide by 6 on both sides. I'm going to write this over here. What are you left with now? Negative 3 is less than y. Now you can rewrite this and turn it around if it helps you, but I really want you to just read your inequality from the variable. So in this case, I'm going to read this problem, this answer, from right to left because the y is starting over there. Y is greater than negative 3. I need to graph this. I like to do at least 3 numbers on my number line. Remember, negatives kind of go in the opposite direction. So negative 4, negative 3, negative 2. They get more negative as you go to the left. Is it an open or closed circle? Well, it's y is greater than negative 3. It doesn't include negative 3 as an answer, so I leave it open. Where are the numbers that are greater? To the right. They're always to the right if you number your number line correctly. Negative 2 is actually bigger than negative 3. Remember, think about where the positives would be. 10, 11, 12, all of those numbers are over to the right, and all of those numbers are greater than negative 3. We graph inequality answers because there are so many answers that we can't possibly list them out. The graph shows where our answers are. All right, let's show them. Ethan starts his bank account with $700 and withdraws $45 per week. Addison starts her bank account with $200 and deposits $55 per week. When will Addison have more money in her account than Ethan has in his account? Write and solve an inequality. Okay, so we have 2 people that we're talking about here. Ethan and Addison. I'm going to use 2 different colors to help me identify the information here. So Ethan has $700 in his bank account and he withdraws $45 per week. Addison is the other person we're talking about, and Addison starts with $200 in her bank account and deposits $55 per week. I think it's helpful to write the names down to start because that will help me to choose my inequality symbol here. So when will Addison have more money in her account than Ethan? I want to know when Addison will have more. There's my inequality symbol. So Ethan has less than Addison, or Addison has more. Now I'm going to fill in for each person here. Ethan was everything that I highlighted in red. He starts his bank account with $700 and he withdraws. What does that word mean? Withdraws means he takes out, he takes away $45 per week or every week. So there's my variable. W, I'm going to define it right here. W stands for the number of weeks. Addison, though, she starts with $200 in her account and she deposits. What does that word mean? Deposit means you are adding to your money in the bank. So she's adding $55 weekly or per week. This inequality has variables on both sides. Look at each side first. Is there anything you can simplify? No. Okay, now we're ready to combine our like terms by getting them all on one side together. I think it's easiest to move your variables to the side where there are more. So when I compare, I have a minus 45W on the left and a positive 55W on the right. I want to move my variables to the right. positive 55 is more than a minus 45. So how do I cancel out this minus 45w? I add 45w to both sides. You can take the variables to the other side. It actually will come out to be the same answer, but your process will be easier if you're always moving your variables to the side where there are more. Now, this looks like an inequality that I've solved before. Isolate your variable by using inverse operations. Awesome, this is looking great here. So read your answer from the variable. W is greater than 5. Again, I do like word problems to have a word answer here. So I'm going to try to write a sentence in the space that I have left. When will Addison have more money in her account? Well, it's when W is greater than 5. So Addison will have more money after 5 weeks. The after is important because actually at 5 weeks, she will not have more money. It says W is greater than 5. So at 6 weeks, 7 weeks, 8 weeks, etc., or even partway through a week. So really after 5 weeks is when Addison will have more money. Good. All right, let's look at the next one. 2 more here. Remember, if you can simplify anything on each side first, that will help you. So when I look at this example 4, I can see that there are multiple B's already together on the left, and there are also multiple numbers already together on the left. Remember to include the sign in front when you are combining like terms. So it's a minus 6b and a minus b. Together, that's going to make a minus 7b. Then I have a minus 4 and a plus 12. So when you combine those, that's going to get you plus 8. All right, so that's less than or equal to 50. Now you can solve. Subtract 8 from both sides. We're using inverse operations here. We get negative 7b is less than or equal to 42. And then divide by negative 7 here. This needs to stand out. This was a rule that you learned earlier in the year, but you may have forgotten it. Guys, there's one special rule when you are solving inequalities when you're solving inequalities. If you need to multiply or divide both sides by a negative number, you have to remember to flip the sign. So I want to highlight this, make this stand out here. Because we are dividing both sides by negative 7, this inequality symbol is going to change. We get B is now greater than or equal to negative 6. You must flip the inequality symbol only when you are multiplying or dividing both sides of the inequality by a negative. It's a special rule. We explained it and talked through why this happens earlier in the year. Hopefully by now you remember it. It says solve and graph, so we're going to graph this on a number line. Negative 7, negative 6, and negative 5. Make sure you have them in that order. You could pick other numbers, but I'd just like to choose the 3 and 1 on each side. This one's B is greater than or equal to, so we're going to have a closed-in circle. Fill it in. That includes that negative 6 is an answer, and we're shading to the right. So all the answers are to the right of and including negative 6. Great. One more for today then. The example 5, solve the inequality and explain your answer here. So we're going to explain what it means at the end instead of graphing. When I look at this inequality, what do you notice? I notice that every term is a fraction. Remember, I taught you this. You can get rid of all of those fractions if you prefer. I definitely prefer it. I think it makes the problem a lot easier to solve. So I'm going to look at this inequality and think, okay, what can I multiply both sides by so that I will cancel out my denominators? 2, 3, and 6 will all cancel with a 6. If it helps you can write 6 out next to each term so you can cross it out. I think that's helpful here. Or you can distribute the 6. Either way, you're going to get the same answer. See, 6 times 3 is 18, divided by 2 is 9k. 6 times a 1/3 is 6 really divided by 3, or 2. And that's greater than 5 6 times 6, the 6's cancel, just 5. That inequality looks a lot easier to solve than what I started with. I'm going to subtract 2 from both sides using my inverse operations here to isolate my variable. And I'm going to divide by 9. Now this fraction can be reduced. So you get k is greater than, I'm not going to leave it as 3/9, and I'm not going to punch it in my calculator. I'm going to recognize that that is a fraction that simplifies. 3 divided by 9 reduces to 1/3. Explain your answer. K can be, any real number greater than 1/3. Perfect. So it could be any real number. That means just the real number system that's greater than 1/3. It could be 2.7639. It could be pi. It could be 11, 12. It could be 100. It could be 1,000,005. All of these numbers, any real number though, so it has to be in the real number system, but it could be a decimal or a fraction or a whole number. I hope this video helps with solving multi-step inequalities.